All right, let's talk about the most important language in the world. It's one you're using this very second to watch this, but you've probably never spoken a single word of it. It's the silent, invisible force that literally built our entire digital age. I mean, have you ever really stopped to think about it? There's some kind of secret code humming away behind your phone, your laptop, every app you open, and every single click you make. So what is this beautifully simple system that's running pretty much everything? Believe it or not, the answer is this. Now, it might look like a totally random mess of ones and zeros, but what you're actually looking at is the fundamental blueprint of our modern world. This is binary. It's a language with just two letters, and it is the rock-solid foundation of everything digital. So let's get a little more specific. A binary number is simply a number that's written in a base 2 system. We live our lives in a base 10 system. We have 10 digits, 0 through 9. Well, binary gets the entire job done with just two, a 0 and a 1. And each of those digits, each 0 or 1, has a special name. It's called a bit, which is just short for binary digit. Okay, but hold on. How in the world do you count, let alone build incredibly complex software, with only two numbers? It honestly sounds impossible, right? But the system is actually really clever and surprisingly intuitive once you see how it clicks. The best way to wrap your head around binary is to just think about our normal everyday decimal system. You know how each spot in a number represents a power of 10? We've got the ones column, the tens column, the hundreds, and so on. Well, binary follows the exact same logic. The only difference is, instead of powers of 10, each position is a power of 2. So you have the ones column, the twos column, the fours, the eights, and it just keeps doubling from there. Let's see this in action, because this is where it gets cool. 0 is 0, 1 is 1. Simple enough, but what happens when we need to count to 2? We've run out of symbols. So just like we go from 9 to 10 in our system by adding a new column, binary goes from 1 to 1, 0. That 1, 0 in binary doesn't mean 10. It means 1, 2, and 0 ones, which, hey, that's 2. And you just follow that pattern. 3 is 1, 1. And then to get to 4, you roll over again to 1, 0, 0. 8 becomes 1,000. See the pattern? Okay, let's try to read one together. Take the binary number 1011. Always start from the right. That first digit is a 1, and it's in the ones place, so we have 1. Next, another 1, this time in the twos place, so we have 2. Then we hit a 0 in the fours place, so we just ignore that one, its value is 0. And finally, there's a 1 in the eights place, so we have 8. Now, just add them up. 8 plus 0 plus 2 plus 1 gives us 11. And that's it. That's really all there is to it. So we get how it works. But that brings up the really big question. Why? Why this system? Why didn't we build computers on base 10? The answer isn't in math, really. It's in the simple physical reality of electronics. And the reason is just brilliantly simple. It's all about electricity. At the most fundamental level, a circuit is either on or it's off. A switch is either open or it's closed. This physical reality of two and only two states makes binary the absolute perfect language for computers. There's no confusion, no kinda on, it's just yes or no, which makes it super reliable and lets us make flawless copies of data. And this simple on-off system is the foundation for things called logic gates, the microscopic building blocks of every single processor out there. But what's really wild is that the elegance of binary isn't just about modern engineering. Centuries before the first computer was even a dream, the philosopher and mathematician Gottfried Leibniz, the guy who formalized the system we use today, saw something almost spiritual in it. He actually thought the two symbols represented creation out of nothing, the 1 being a symbol for God and the 0 being the void. And Leibniz, it turned out, was tapping into an idea that is just shockingly ancient. See, binary isn't some newfangled computer age invention. Its roots stretch back thousands of years and pop up in cultures all over the world. The history here is just incredible. We're talking about binary concepts showing up in ancient Egypt over 4,000 years ago to measure grain. It was in 9th century BC China with the I Ching used for divination. And in ancient India, it was used to describe the rhythms of poetry with long and short syllables. It wasn't until Leibniz in 1679 that the system was all formally written down. Then, centuries later, George Boole gave it its logical power with his Boolean algebra. But the real game changer, the moment it all came together for the modern world, was in 1937. A guy named Claude Shannon wrote a paper showing how you could use these ancient ideas with simple electronic switches. And right there, the modern computer was effectively born. So, when you put it all together, the story of binary is, well, it's pretty remarkable. It's the ultimate story of taking the simplest possible system you can imagine and building a universe of infinite complexity on top of it. And that, right there, is the big takeaway. Every photo you share, every song you stream, every complex calculation guiding a probe to another planet, all of it, everything, boils down to an incredibly long, mind-bogglingly intricate pattern of just two symbols. On and off. Yes and no. A 0 and a 1. A profoundly simple code literally built the world we live in today. It really makes you wonder, doesn't it? What's the next simple, elegant idea that's out there right now, just waiting for someone to find it, that's going to completely shape the world to come?